Okay, so simple surfaces that were used more or less to generate this, and there are some issues that I can already see that might be problems with the model and what I'm asking you to do, at least the one that I've generated here, so something that you want to be aware of. We can see that, and I'm just going to explode this quickly, that this surface right here has double curvature, right? And so it's a twisted plane. And as we bring this into 123DMake, that prevents a set of issues. Not necessarily with interlocking planes, which is one way I'd like you to think about generating the mass of this thing, but also for the folded planes that I'd like you to look at. So that'll present somewhat of an issue, although it's definitely workable. There's another one here to the opposite side. The rest of these are much more slight in terms of their twisting. So this isn't quite as bad as the other, and some of these are just flat. So again, you can imagine this being generated in a similar way that I showed in the last workshop. A lot of this too, and I'll just delete this to show just a simple example. If this was a component that was lifted up from the ground plane and rotated into place, and perhaps this is an area that needs to be enclosed, I was really just using simple surfaces and actually this tool right here where you can use 3 or 4 corner points. So I can connect each of these corners to create that surface. Of course, we have to make sure that generally we're working with these straight edges, right? That's important. We don't want any openings to happen there. So keeping things, for the most part, angular is going to be your friend in this process. So the other thing that I did then was just to join all of that. So I made sure it had a bottom because I want to make sure I'm able to use the interlocking planes. So I'll go ahead and just join that. And then I went through the process of exporting selected as an STL file. And that's what I ended up generating there. So I already have that saved though. So now this was brought into 123DMake just using the import tool that you've previously used. And I'm going to get this back to interlocking planes. So this is one layer that I'd like you to work with in the relief construction models. Some of this massing might include all of the spaces, or you might do these separately and then position them together on the base. But this is one of the layers I'd like you to begin to use and implement as part of the massing of this. Not only the massing, but also a way to also explore some of the architectural languages that you might consider with this piece. And again, you can make sure you have the right media selected, make sure your scale here is appropriate, similarly to what we did with topography. This model right now isn't necessarily to scale, but again, you can check the scale between Rhino and this to make sure you have the right height for the 16th inch scale that I'm asking you to use. And then select your interlocking slide or your construction technique, essentially. The number of these as well, it's up to you to work through. Of course, you have to begin to factor, some of these pieces that might be flying off on their own, but something that's going to help you advance your overall design thinking with this project. So let's start to work with those then three-dimensionally using this tool. Also, what I'd like you to do is think about them or using this same model as a skin for the mass itself. And the way I'd like you to do that, you may not use all of the skin components, and it's up to you if you'd like to delete some of these. So there may be areas where this is exposed and other areas where you have a skin sort of wrapping. So we have an idea of massing, we have an idea of the materiality in terms of the skin, and then we also have an understanding of kind of the inner, something that might emerge as being structural, which this could be gesturing towards right here, the interlocking planes. So the other technique I'd like you to use is folded planes. Now, when you use folded planes, there are some things you have to consider, and right now looks like I only have one model issue, and I'll let you know why that's the case. So basically what this is going to do is take this poly surface and now understand the surface of this overall model, and basically unroll it, not unlike the unroll developable surface tool that I showed you in Rhino, but in this case it's going to give you a numerical value for each of these panels, so you know which one interlocks with the other. It's also going to give you a technique for mending these together, right? And so there are a variety of seam options that you can work with here. So right now I have it set to what's called gear here down below. So I'll show you, and the other thing that I have selected as well is perforated. And so basically this is divided up into a series of panels. The panels that are independent have gear connections that will then be connected to the next panel that's a free panel. Those panels that have folds in it, actually 123DMake is creating a perforation pattern, so it's easier for you to fold it in one direction or the other. So we basically get the pattern for this overall mass here. So I'll have that checked, perforation, and we see the gear. Now I'm just going to go to get plans and you can see what the gearing does. So basically this automatically creates these slots. The neighboring panel, the adjacent panel will fit right into the other slot, not unlike a zipper, right? So it gives you a nice simple strategy to fit these together, and some sort of surface area for the gluing itself. Now, there are other options, and it's up to you if you'd like to use some of these other options. I think gear is the most straightforward. There's one that's called a diamond. So basically what that is, just a series of these small tabs, these little small tabs here that get folded down to the neighboring panels tab, and those would be aligned, and that's where you would glue it. So it's a little finicky, you know, but that's another option in this case. Laced. This, and you can change, I believe you should be able to change the size of this somehow, but basically what it does is gives you a series of holes where you might lace this together with some kind of string or what have you. Puzzle, I haven't really looked at all of these, or this is multi-tab. So you can see here where this is going to fit in to another tab, which would be here. So those kind of interlock. I haven't seen anybody use this one before. There's one, let's see, puzzle. So it's more like puzzle pieces that end up getting fit together. Rivet, again, is a series, it would be a series of holes, and those could be riveted together, so some kind of small stud or something like that to fit those together. I'm not sure what seam is. So that just gives you an overall seam here. It includes the diamond tabs. So it just gives you a little bit more material to work with, it appears. The tongue, and so basically you can see a connection right here. So here's a tongue sticking out as a kind of a tab. That would then slip into this slot theoretically. You have to think about the material that you're working with and the thickness of it. With chipboard, I'm thinking these would turn into a mess. But feel free to try it if you'd like to. Let's see, tab. So a series of tabs that then fit into these slots. See how those connections work. Ticked. So it looks like they just give you measurements here. So this would be etched onto the panel so you can match those up, I would imagine. So it doesn't seem to have an exact connection type there. But geared is the one that I think tends to be the most reasonable. If you go into edit, you can start to modify some of the characteristics. So in here, you'd be able to modify the radius of some of these if you would add, just similar to how you add material. So you could adjust the size of the holes or the size of the tabs and so forth. So here I just hit the plus. It's unnamed right now. Units are inches. It's set to gear. I can select any of these. Let's say the laced, and then I could start modifying the size of the holes right here with these toggles. So you'd basically create another joint preset. And then you go through the process of getting plans and exporting and so forth. Now, depending on your form, you may have a lot of errors. And there was a lot of errors with this piece because of those double curved surfaces. So you can see here, and I can go down to this tool right here, and I can select add and remove seams. So I can add seams, remove seams. If I want it to be more folding and less individual panels, I can start to control that. So the thin lines are just would just be a fold, more or less. The thick lines now are actual seams. And if I just click on one of those, I can remove them, and I can add them in another instant here. And if you notice at the bottom, there's this button that says done. So what that's going to do then is saying, okay, you made the changes that you want to make, and now it's going to run it through the routine of understanding how it's going to then work with the geared connections and so forth. So if I hit done, we see here I have a couple red panels. Those have problems. The problems that I have seen, for the most part, it's a little bit hard to see with these, but basically it's with the geared connection in this case. So you might be able to modify the depth, but basically what's happening is that the geared opening, so the negative space where another gear would sort of fit into, basically subtracts away from the overall surface. So it's too thin. Its thickness is, I guess, thinner than the overall size of the gear itself. And so you can see here there's a break in that. And if I go to get plans, it's a little bit easier to see here. So this is basically an overall triangular wedge, and we can see the gears that are trying to be created there, but because that is thinner than the actual two gears that are there, it creates an error, right? And so going back and forth, so if I add one here and remove that, that gives me a little bit more space. I see that there's another seam right there. I'll remove that. I'll say done. That seemed to fix it because now these are wider than those slots would be, and there's not an error. So you might have to go around and make some of those kinds of changes, especially if you have double curved surfaces. Let's move it. Move. And some of them just might be kind of difficult to work with. This area I wasn't quite able to craft, and I think it would still work, although that long edge would kind of go away. So that's something in the model I might just have to change by hand and create another piece. Well, you can basically see I divided these up into a series of panels. Now if I removed that seam, that means that that overall panel is going to be that long. It's going to have a perforation there so you can fold it. Create some other issues, but then we see how that works out there. That's actually piece one, right? And so we can see one-to-one how adding or removing some of these seams affects the overall construction technique. You can also just split all of the panels. So if I select this, it's just split all the panels down to their bare essence. So there's no folding, basically. This might be a little bit crazier to build because you have all the little pieces together instead of having some folded pieces. And so, that's something that you could try if you'd like to, but I think trying to work with the folds and the seams makes a little bit more sense just for constructability. So then, of course, you'd go to Get Plans, make sure, I guess it's already pretty much nested. It's not letting me change that. Export it as a DXF, and then you would bring it into AutoCAD with the template file for the laser cutter and make those same kinds of modifications that you did for the topography. So basically there would be two steps using 123DMake. One would be making the folded panels, and the other would be making the interlocked slices. What was that? Yeah. Keep in mind for the end of this, so this model is due basically when the overall project is due. And so basically what I'm asking you to do with this is carry it through as a finished concept model. So a well-crafted concept model. So these ideas may be a little bit more abstract than an actual finished model that's depicting the exact architecture. So there might be some abstraction between that and the drawings. Now, the overall form, the overall footprint, the main sort of gestural quality of what the model is about should be what the project is about. But I'm letting this be a little bit more about ideas in terms of using some of these other tools as opposed to creating an actual finished presentation model that's exactly what's in the drawings. But the form, the geometry, ideas that are derivative of the photo montage, those should all be part of the finished project itself. Does that make sense? Yes?
So you don't actually want a presentation model,
These will be presentation quality concept models. Does that make sense? Sure. So they're not meant to be sketch models or quick models. I want you to spend time and really craft these models, although some of the content will be more abstract and conceptual. Like, for example, you're not going to have all these interlocked planes within the architecture itself, right? But it might be derivative of the structural system, might be derivative of the articulation of the material skins or the envelope, and so those relationships should be there. Other questions?
So this model is for one building or for the whole thing?
It would be for all of the buildings. I'm just showing this as an example, but yours would include all of the programmatic spaces that are listed in the program.
Mm-hmm. But we need to use both interlock and fold. Right. For only these two types for the whole thing, or make two models?
One should wrap the other. So the idea is that these both are part of one single model. So basically the interlock planes end up being the structure for it, that's going to hold it up, and then the other material panels then become the skin. And as you create the skin with the folded models, keep in mind some of the other things that we've been talking about, construction technique. And so these are the panels that you'll be creating. but keep in mind the other architectonic expressions that you're working with. So if there are bits of text, if there are other patterns that you want to be present on these, that's something that then could be overlaid onto this and either etched onto these panels or actually cut through these panels if it's a series of other kinds of openings that are coming from the abstract expression. So if there was like a perforation pattern or a series of circles, I can basically create those circles using Rhino, bring those in then to the same file as the laser cutter, put those in place, make sure they're in the right scale, and modify these panels so they become a little bit more expressive. So you might be able to see through some of these panels to the structure that's within it. So you can modify the nature of these. These can be textured or perforated, what have you. They don't have to necessarily remain solid. But those modifications, they might also include text, because I'm asking you to use some of those tools to create outlines and so forth to create text. So it might be the text that's part of this as well.
So we need to build the texture in Rhino and then bring to Rhino.
Yeah, that would then be exported right from Rhino straight into AutoCAD, and then you would have it in that laser cutting file.
So we don't need to bring into the raster, we can...
You wouldn't have to. If it's just a 2D pattern that you've created, then that's something you can just bring directly into AutoCAD over these. That would have to go through 123DMake.
So what about the one last class you talked about with the 2D layout, the nested 2D layout with the axials?
The structural system. I mean, I was showing you that as another possibility, perhaps for the interlock planes. If you want to do that instead of the interlock planes, that's fine. But I'm showing this as another example, letting it be more part of a concept model. And so the other kind of sectioning tool that I use, that's also a possibility to express the structure. So I would say you could either use that or these interlock planes if you'd like. That might be a little bit more difficult just to create an overall structural system before this, because you'd have to basically do a lot of that, add a lot of that information. And there might be just some information left over depending how elaborate your model is.
So should the interlock model be smaller in the scale than the wrapped model, because the wrapped is inside?
You might consider upsizing this maybe by 1/16 of an inch. And so if you just make it a little bit bigger to wrap around the interlock planes, that would probably be enough. So the question was, because you have this on the inside, and this is all based off of the same geometry, and then you have, so that's the interlocking planes, then you have the folding planes over that. Will those compete because the outer limits are occupying the same space? And so what I was recommending is just to take any one of these. So say, for example, I'll take the 12 inches in this case and add a 1/16 of an inch. That'll just make it a little bit bigger. I'll have to make some of the other adjustments because now it's falling off of the sheet here, but so then that just makes it a little bit bigger overall, and then that should give you a little bit of room to work with with the panels around the interlocking planes. So I think just bumping up that scale just a bit will get you there. You don't have, again, you don't have to use all of those folded panels. There may be some areas that you just want to be more open, that's about glazing or something, and then you would just leave the interlock planes exposed in the model.
Like the openings or circulation?
It could be for circulation, depends on the geometry, depends on what you're working with. But if there was, one of these, say for example, I wanted this whole area basically to be glazing in my project, I would just leave those panels off.
So what about should we show the doors or the windows?
Again, well, the question is how to show doors or windows those should, this is a concept model, so keep that in mind. But doors and windows, again, should be coming from the nature of the photo montage, the relief construction, so they should be derivative. So they should work together, more or less. But this could show some of that if it's like abstract ideas for windows, what have you, and you're still kind of experimenting with that. But for the most part, those can be in the drawings, because this will be supplemented with the drawings. So in this case, while it's failing here, all of these pieces is one, this is all one big connected piece, and it's too big for the sheet, so I'd have to create another seam to cut, or a few seams to help divide it up a little bit more, so it would fit appropriately. That's why a lot of this is failing. Okay. So, going into next week, and during studio today, you'll have time to work on this. Of course, we'll be working on some other things, the perspectives, but also in studio to work on the digital massing model coming from the relief construction and starting to work through and walk through some of these steps. So I want you to be able to do that and use studio time for that today. For next week, basically I'm asking for refinements of all the orthographic drawings. And so looking at the plans and sections, the elevations, making sure that those are being developed and coming along in terms of a design logic along with these models. Should begin to articulate materiality, a solid textured material, something that's opaque, translucent and transparent material, so basically glazing, and some idea of structural system. I say here a hybrid structural system, meaning that some of the opaque walls may end up, or thick solid walls may end up being load-bearing walls, and some of the framing pieces, the rest of the skeletal system may sort of lean on that, and that would then be a hybrid system, as opposed to it all being load-bearing or all being a frame. So that's what I mean by that hybrid system. So you might share a little bit of both. And then a physical relief construction model with the massing, having gone through 123DMake, and so a version of that. If you would, now the final model will be at the 16th inch scale. You see down below. For Tuesday, if you wanted to do a smaller model, so something at a smaller scale, I don't know if it would get too tiny, but you can experiment with other scales, because basically I want this to be a study before you do a refined one for the final, right? So if you want to experiment at a slightly smaller scale, you can do that as a step going towards the 16th inch scale model. That'll be for the final. Does that make sense?
So the drawings can we digitally print out for the plans section elevation?
The question is whether the drawings are digital.
Or manual drawing.
They should be manual drawing, hand drawn.
Can we do like half?
Can you do half-half?
Yeah.
A hybrid? Well, now you'll be developing the model digitally, and so it's very easy then in Rhino to get an overall idea for the massing, and I can print this out again to scale, similar to the steps I've shown before. So I could select a scale here and print that out and use that basically as the underlay for a drawing you would develop. So in that sense, yes, like that one could sort of work from the other. So you can set up the drawing using some of the tools here, or some of the views here for the front and the side and so forth. So you can do that. If you would like to, for a section to have that start using that, you can use what's called a clipping plane. And so I'm just going to make a simple clipping plane through this object. And I just typed in CL, and the command comes up as clipping plane. I'll hit enter. First corner of the rectangle, so I'm going to go into, say, this view and draw a rectangle. Now that's a clipping plane, and those also can be on a specific layer. Everything right now is just on default layer, so I'm being a bad layer manager right here. But I would also just put those on another layer, because that line work could potentially show up as you're printing and so forth. So you might just want to shut those off. But basically then what I'm able to do, I'll go back to a top view. I'm going to find that clipping plane. I'm going to make sure it intersects the object. Now, right now it's not doing anything. And I have to go into Properties. And then there's a little toggle here for the clipping plane itself. And basically the only viewport right now that's going to be responsive to the clipping plane is the right view. But I can change that by toggling the others. So now I selected all of the views. And you can see it took a cut right through that. So then if I go to, actually I think I want to, oh, there's the cut right there. So we can see the cut line right here. So that could potentially, be the beginnings of a section drawing, essentially. That would also show up then in the top drawing. You guys have a question? No. The other thing that you might consider to work with in thinking about translating or transferring drawings from Rhino to hand drawing, and this might be good for the perspective drawing. So I'm going to turn off this clipping plane, just in the perspective view. Is that I can do something that's called Make 2D. Command called Make 2D. So say this is the view, I'm happy with this perspective view, and I can go into viewport tab, and then this is the lens length. So it's not very clear as an icon, but this would be the set the lens length. So I get these little cameras, and I can change the camera angle. So you can play around with the angle of the camera itself, or the lens. So say that's the view I wanted to work with as a beginning perspective. I can select that, and then I'll just start typing in make, and then Make 2D comes up. I'll hit enter. It's going to ask me for some various options. Drawing layout current view, that's fine. You can or cannot, it's up to you, show hidden lines. They'll actually come up as separate layers. And usually most of these, you can play around with some of the options here, but generally besides hidden lines, I don't typically work a lot or change a lot of the defaults. So I'll hit enter. So what that automatically did was take that view and create a 2D drawing and place it on the construction plane for me. So when I go to top view, I have the lines of the perspective drawing right there. And you can see now the white lines are actually the hidden lines, so those are the lines behind, and they actually should have created its own layer. So we see here Make 2D, and automatically create a layer for visible lines and then hidden lines, but it's a flat drawing. So again, if I look at it in perspective, it's just on the construction plane there. So I could do that for a section, elevation, what have you, to create that. And if you wanted then to bring it into AutoCAD or use a different kind of tool for that, or just print it out, then you can use that as well. This is something that you also could then export into Illustrator. So you can just export this as an Illustrator file. Export selected, and Illustrator should be in here somewhere. There it is. There'll be Illustrator. And then once you export that, you can open it up in Illustrator, and basically it'll be vector line work. And there you can change the stroke of some of those lines, make them thicker or smaller. You can kind of fill in some general areas, so you can work with it in Illustrator as well, and to have it be a clean drawing. But I do want you guys to work on these drawings by hand, but you might use this as a beginning template to help set up the drawing. So depending on how detailed that is, that might be a good step.